Hi students, in the previous video we have just taken that what is meant by maxima and the minima. Apart from that, continuously we just say that a local maxima and a local minima. When we need to say that the maxima and the minima, and when we need to say that local maxima and the local minima, one more is the absolute maxima and the absolute minima. Now in this video we will come to know that what is meant by local maxima and the local minima. Already you know that in a previous video, that is maxima and minima. Suppose f is a real valued function defined on an interval I, then there exists a point. Then f of c is greater than f of x. There exists a point c such that f of c is greater than f of x. In this case, we have to say that f of c is the maximum value. If it is inequality is less than, then in this case we have to say that f of c is minimum value, where c is the point of maxima, where c is the point of minimum. We have just know in a previous video. Now in this video we come to know that when we need to say that local maxima and the local minima. For that, I just consider one function. Let y is equal to f of x be a real function. Be a real function defined on an open interval I. Defined on an open interval I. Suppose the graph of the function is like this. Suppose the curve or function might be like this. Not exact one. Suppose it might be like this. How it is? Okay. This is the graph inside. It is defined on an interval, open interval a comma b. This point is a and this point is b. It is defined from a to b. This we can say that x is equal to b. This we can say that x is equal to a. A function y is equal to f of x. The graph of the function is like this. So whenever you just discussing the maxima and the minima, you just taken this curve maxima and you just taken minima in this type you just taken. But in this time it depend on the interval only. But here the graph is like this. Can we say that this is the maximum value as compared to this one? Here this is maximum, this is maximum, this is out of all these value maximum, maximum, maximum. Here it is a minimum, minimum, minimum is there. There are 3 maximum value and 3 minimum values are there. Out of all these value, which one value we have to consider as a maximum value? So, for considering the maximum value, the word is named as a local maximum. Locally. So, we have to choose the maximum value locally. Okay, for example, your second PUC result is going to produce over the state topper, district topper, taluk topper and city topper, college topper, like that. At different stages of the toppers, we can get the result of topper for our college, topper of the taluk, topper of the district, topper of the state, topper of the nation, like that. We have to choose in that manner. So I am just choosing the locally. I am just choosing the topper of our college in that manner. There are so many toppers are there. Out of that topper of our college. Okay, I got my point. Now let's come to know that here I need to choose. So here a to b interval is that in this interval a function is defined. It is a continuous function on an interval I, open interval I, and differentiable also. And now here what I just do. Suppose the point is that this is the point. As we observe that at this point, I just call this is the point c, x is equal to c. Can I say that this function at this point, the first derivative at this point is 0, or else we can say that the slope of the tangent is 0. Slope of the tangent is 0 at this point. Now, what I just say that this is the local maximum value. This is the local maximum value. Where it is from, where it is means from the interval. Here I just change the interval. How I just change the interval means this interval is c minus h comma c plus h. In the interval c minus h comma c plus h. What is h? H is the very small positive quantity. H is the very small positive quantity. I got my point. I am just telling that this point, or else I just write it as a C1. C1 minus H, C1 plus H. C1 is the local maximum value in the interval C1 minus H comma C1 plus H. Here it is looking at the maximum value. So that I am just taking another interval in that sub interval only. In this interval I have just taken a sub interval, that is a C1 minus H comma C1 plus H. In this interval at the point C1 it is a local maximum value. Similarly, I need to discuss the minimum value. So minimum value, I just say that this is the minimum value. At this point, we can call it as a C2. Where it is the minimum value in the interval C2 minus H comma C2 plus H. C2 minus H comma C2 plus H. It is a local minimum. And again, if I have taken this point as x is equal to C3. Here I just write x is equal to C3. C3 is the local maximum. Again, this point we can consider as a C4. X is equal to C4. C4 is the local minimum. C5 is the local maximum, and C6 is the local minimum, like that. Locality. In that locally we have to discuss the maximum value and the minimum value. Instead of taking the whole interval, I just taken a small interval around that given or around that critical point. Already you know that critical point. What is meant by critical point? Increasing, decreasing, where the curve is changes its direction. Where the curve is changes its direction. It is increasing. At the point C1, it changes its direction to the decreasing. Now decreasing. At the point C2, it changes the direction decreasing to increasing. So locally which value is maximum, that is our local maximum. There are on a broad domain of the given function, there are so many maximum value, minimum values are there. Out of that, I am just choosing the local value. Are you clear? For example, once again, in our district, there are so many colleges are there. Apart from that, so many toppers might be there. So individual college. This is one college topper. This is another college topper. This is third college topper, like that. Out of that different college, I am just choosing the one that college, the particular college topper, particular second college topper, particular third college topper. Similarly, particular first college lowest result, particular second college lowest result, particular third college lowest result. In that, out of that all the colleges of the district, I am just taking one particular college topper. That I just say that we have to say that local maximum value, local minimum value. Now, apart this is the basic thing. Now let's come to know that what is meant by definition. Definition is here as a statement. Let or f be f or f of x be a real function dependent on closed interval or open interval y, and x is a very small positive quantity. Then f function f has a local maximum value. F has a local maximum value. When it has a local maximum value, means whenever f of c is greater than f of x. F has a local maximum value. When it is f of c is greater than f of x. When it is for all x belongs to what? This c minus h comma c plus h. X belongs to the c minus h comma c plus h. Then this f of c is called a local maximum value. F of c is called a local maximum value, and c is called a point of local maximum. C is called a point of local maximum. Similarly, second case, f has a local minimum. F has a local minimum and it has whenever there exists a point C, f of C is less than f of x for all x belong to the C minus h comma C plus h. C minus h comma C plus h. In this case, f of C is said to be a local minimum value. Local minimum value, and C is said to be a point of local minimum. Point of local minimum. This is how. Then the third case. What is the third case? Means first case is local maxima, second case is local minima. So here local maxima and the local minima is clear. Now I just take one theorem. What is the theorem means? Suppose or let f be a real function. F be a real function defined on an open interval I. F be a real function defined on open interval I. Here domain of the function is this open interval, and there exists a point C which is belong to the open interval I. C is any point defined on a domain of the definition. Then f has exist or f has a local maxima or local minima. F might exist a local maxima or a local minima. When it exists, or then only when f dash of x is equal to 0 or the f is not differentiable. F is not differentiable or f dash of x is equal to 0. What is the meaning of the theorem? Suppose f is a real function defined in an open interval I. There exists a point C which is present in a interval I. Then f might be exist a local maxima or a local minimum. Suppose it exists a local maxima, then f dash of x is equal to 0. Then f dash of x is equal to 0. Suppose it exists a local maximum value is that at this point the f dash of x is 0. F dash of x is equal to 0 means slope of the tangent is 0. Or else local minima is the slope of the tangent is 0. Local maxima, tangent, slope of the tangent is 0. All these maxima or minima locally it has slope of the tangent is 0. Apart from that, or else f is not differentiable, or else another case is f is not differentiable. For example, suppose the curve is like this. For example, we can say that function f of x is equal to x minus 1 is that. F of x is equal to x minus 1. Define an interval, closed interval 1 comma 3. Define an open interval 1, closed interval 1 comma 3. On looking this function, f of x is equal to x minus 1, it is a linear equation. Linear equation means a straight line will get it. So how it is? If we choose an f of x as a y is equal to x minus 1, y is equal to mx plus c, the line will come in this manner. Define the interval where to where? From 1 to 3. 1 to 3 is that. So that this type of function. So f is not differentiable. Where it is not differentiable, at the end points it is not differentiable. Are you clear? At these two end points it is not differentiable. In this case also it is exist a maxima and the minimum value, particularly local maxima and the local minimum value. Already know that in a differentiation, that is function is continuous in a closed interval and differentiable in the open interval. Differentiable in the open interval, but I have given a closed interval. So at the end point, the function is not differentiable. Why it is not differentiable? Means we cannot draw the tangent at the end point. We cannot draw the tangent at the end point. So that reason it is not differentiable, but it has a local maxima as well as the local minima. One more graph please. So here, is it exists a local maxima and the local minima? Yes, at this point, it is differentiable. F dash of x is equal to 0, slope of the tangent. It is local minima. Slope of the tangent is 0. But it is at this point, these 2 points, we can say that it is the C1 and the C2. C1 and the C2 point. At this point we can differentiate, no problem. Slope of the tangent is 0. But at the C1 and C2, the function is not differentiable. At the C1 and C2, function is not differentiable, but it exists a local maxima and the local minima. Are you sure? Whenever the f dash of x is equal to 0 or f is not differentiable, in that case also local maxima and the local minima are exist. So whenever, or else one more function we can say that modulus function, there will be that shape of the modulus function is like this p shape. So at the x is equal to 0, function is not differentiable. At x equal to 0, function is not differentiable. Other than that point, remaining all the points, the function is differentiable. Modulus function in a continuity and differentiability, we have just already proved this condition, taking the LHD, RHD, we have just proved that. So that we can make one hint. Whenever the graph of the function has the sharp edge, graph of the function has a sharp edge. In that point, the function is not differentiable, but it exists a local maxima and the local minima. Okay. We'll take the next one, that is theorem number 1, based on the local maxima and the local minima. Suppose if they given us some f of x is equal to polynomial function, we need to find the local maxima and the local minima. To find the local maxima and the local minima, previous video we just found the maxima and minima. In the same manner, here we need to find the local maxima and the local minima. For that, one theorem is that using this theorem we can easily find the local maxima and the local minima. The name of the theorem is first derivative test, which means that using the derivative, first derivative, we can easily find the local maxima and the local minima. Okay, what is the first derivative test? It says that suppose f is a continuous function. Suppose f is a continuous function and an open interval I. Suppose f is a continuous function and an open interval I, and there exists a point C is belong to the open interval I. Then the first case is, and as well as it is continuous and as well as it is once differentiable. We can say that. Suppose f is a continuous and differentiable on open interval. Continuous on a closed interval and differentiable on the open interval. Then there exists a point C is belong to the interval I. Then here I need to come to know that local maxima. When we need to get the local maxima means suppose or if f dash of x is nothing but slope of the tangent to the curve. F dash of x is changes the sign. F dash of x is changes the sign from positive to negative. F dash of x is changes the sign from positive to negative. Then throughout the point and at x is equal to c. F dash of x is changes the sign positive to negative at x is equal to c. Closer, very closer to the c. Then the f of c is said to be a local maximum value. F of c is said to be a local maximum value and c is said to be a point of local maximum. Point of local maximum. Once again, very clearly see the or listen the statement. Suppose f is a continuous function on I and differentiable on that same interval I. There exists a point C in that interval I. Then if suppose f dash of x changes the sign from positive to negative. What is meant by f dash of x? First of all, given function first derivative. First derivative is nothing but slope of the tangent. Slope of the tangent is changes its direction from positive to negative. Tangent slope positive, when it is a positive, when it is a negative, already know that. Angle between the line and the x-axis is acute angle is a positive slope. Angle between the line and the x-axis is obtuse angle more than 90 degree. In that case, it is a negative slope. Already know that. Suppose in xy quadrant, this angle is acute angle, positive slope, and suppose this angle is obtuse angle. In this case, negative slope is there. Now, slope of the tangent is changes its direction from positive to negative. It changes the direction from positive to negative. In that case, at very closer to C or at x equal to C, then f of C is said to be a local maxima and C is said to be a point of local maxima. How it changes means clearly I just take the one diagram or else I just draw at that side. Suppose the function is that this is the y is equal to f of x. Given function is continuous on an interval I from interval a to b. It is continuous as well as differentiable, nothing to worry. Now here I just take that. What is the critical point? Critical point means where the curve changes its direction. This is the x is equal to C. On C, this one we can easily say that this is the maximum value. F of C is the maximum value. F of C is greater than F of x. First definition already know that in the local maximum and the local minimum at x equal to C. It is the maximum value as compared to the F of x other values. Now, very closer to the C at x is equal to this point. At this point. What is the slope of the tangent? Slope of the tangent is nothing but suppose the tangent is like this. What is the slope of the tangent? Is it a positive slope? Yes. Extend this line up towards the x-axis here. What is the angle between the line and the x-axis? Acute angle. Slope of the tangent is positive. Clear? This is. Suppose if you draw the tangent at this point. Draw a tangent. At this point, tangent is the what is the angle between the tangent and the x-axis? Acute angle, positive slope. Suppose you will draw a tangent at here. Okay, what is the tangent? This is the tangent. Acute angle. Yes, it has the positive slope. So on the left hand or left side of the point C. Left side of the point C in front of you, the function graph is the C. Left side is the left side. On the left side of the C, the f dash of x is nothing but slope of the tangent is positive. At the beginning, it is a positive. It changes the sign. F dash of x is changes the sign. Positive to negative. Positive into the negative at this point. If I draw a tangent, what is the slope of the tangent? We cut the x-axis at here. The angle between the tangent and the x-axis is obtuse angle. It is a negative slope. And at here, it has a negative slope. Obtuse angle. Are you clear? F dash of x, slope of the tangent, changes the sign from positive to negative. Then has a local maximum value. It has a local maximum value, and C is said to be a point of local maximum. At this point, x is equal to C. Whatever this is that, this is the point of local maximum, and f of C is said to be a local maximum value. Very simple. At this point C, the f dash of x is equal to or f dash of C is equal to 0. First part is clear. When we get the local maximum value, we will get the local maximum value whenever f dash of x changes the sign from positive to negative. Positive to negative. Next, second case. If f dash of x is changes the sign, f dash of x is changes the sign reverse, negative to positive. Changes the sign from negative to positive. F dash of x is changes the sign from negative to positive at x equal to C. This is the x equal to C. Left hand side of the C, slope of the tangent is negative. Right hand side of the C, slope of the tangent is positive. At x equal to C, f dash of C is equal to 0. Left hand side of the C, slope of the tangent is negative. Right hand side of the C, slope of the tangent is positive. Suppose f dash of x changes the sign from negative to positive. In that case, or at x is equal to C, then f of C is said to be a local minimum. F of C is said to be a local minimum, and C is said to be a point of local minimum. C is said to be a point of local minimum. Are you clear? Once again, check. Suppose f is a continuous function on I and differentiable on that interval I, then there exists a point C belong to the interval, then f is once differentiable, okay, or whatever, okay. If f dash of x, slope of the tangent, E changes the sign from positive to negative, then in that case it has the local maximum value. And f of c is the local maximum value, c is the point of local maximum. If f dash of x changes the sign from negative to positive, in that case f of c is a local minimum value and c is said to be a point of local minimum. C is said to be a point of local minimum. Okay. Third case is, suppose f dash of x does not change its sign. F dash of x does not change its sign. F dash of x does not change its sign, then in that case it is said to be a point of inflection. In that case it is said to be a point of inflection. For example, suppose f of x is equal to x cube is the, what is the graph of the function f of x is equal to x cube? This is the graph of the function f of x is equal to x cube. Suppose f dash of x does not change the sign throughout its domain, then in that case it is said to be a point of inflection. Here, what is the slope of tangent at this point? Slope of the tangent is positive. Now in this case, at this point, slope of the tangent is positive. In this case, slope of the tangent is positive. At this point, slope of the tangent is positive. Throughout its domain, the f dash of x, slope of the tangent, does not change its sign. In such case, at x equal to 0, at whatever the point which is taken, at f dash of x at x equal to c, this point is said that point of inflection. The point is said that point of inflection. This is the first derivative. So f is a continuous function on I. C is any point belong to the interval, and f is differentiable. If f dash of x changes the sign from positive to negative, it at the beginning on moving x from left hand side to the right hand side. Point left hand side to the right hand side, it changes the sign from positive to negative. In that case, it is a local maximum. If it changes the sign from negative to positive in this sign, it is a local minima. If it does not change the sign, in that case it is said that point of inflection. We just mentioned this theorem and these particular graphs at the side of these particular three cases, we come to know that clear picture on graphically as well as words. Now let's take how to find the local maxima and the local minima using the first derivative. Yes. Based on the local maxima, local minima theorem, first derivative test. Find all the points of local maxima and local minima of the function f is given by f of x is equal to x cube minus 3x plus 3. It is a cubic polynomial. Cubic polynomial is that means already know that in this type of problem is solved in increasing and decreasing. Find the interval in which the given function is increasing and decreasing, strictly increasing, strictly decreasing. In the same manner, we have to find the points at which point it has the local maximum and at which point it has the local minimum. Points are there, more than one point. Cubic polynomial is there, obviously. So first derivative test I am going to use. To use the first derivative, the definition is says first derivative f dash of x. So first find the f dash of x, and after finding the f dash of x, at which point the slope of the tangent is 0, because local maxima f dash of x is equal to 0, local minima f dash of x is equal to 0. It must have the slope of the tangent. Already there is just taken that before the first derivative test. The function is exists a local maxima and the local minima. It should have f dash of x is equal to 0, or else it is not differentiable at x equal to c. So that it must have the f dash of x is equal to 0, because increasing to decreasing. condition you have to get. So that given solution. So given this equation is called as a 1. Differentiating with respect to x. What is the f dash of x? F dash of x is equal to x cube differentiation 3x square minus 3 into x. Better to write in a factorized form. So 3 is common. X square minus 1. Again I just write 3. X square minus 1. A square minus b square. A plus b into a minus b. This is our f dash of x. So we have to get the it must have a f dash of x is equal to 0. That means we need to find the critical point. Find the critical point. How to find the critical point? Suppose f dash of x is equal to 0. Suppose f dash of x is equal to 0 means what? 3 into x plus 1 into x minus 1 is equal to 0. Product of 3 number is equal to 0. Any one of the number is 0. 3 is never becomes a 0. So either x plus 1 is equal to 0 or x minus 1 is equal to 0. Which means that either x is equal to minus 1 or x is equal to plus 1. Here we have a 2 critical points. At these 2 critical points, function changes its direction. However, whether it is increasing to decreasing or decreasing to increasing, we don't know. Whether this point is x is equal to minus 1 and this is x is equal to 1, or this is the minus 1 and this is the plus 1, we don't know exactly. So I am just going to find. So here, suppose I just take that a real number line, positive infinity, negative infinity, points minus 1 and points here plus 1. So we have to recognize that f dash of x changes the sign from negative to positive. So what we are going to do is left hand side of the minus 1. Left hand side of the minus 1, because at x equal to particular point C, left hand side of the C, whether the slope of the tangent is positive or negative. At x equal to minus 2, left hand side of the minus 1, minus 2 is there. Now check the f dash of x sign, because f dash of x positive or negative, we have to get it. Check at x equal to minus 1, it has a positive or negative. At x equal to minus 2 is that minus 2 plus 1 minus, it is a negative, and minus minus. So it is minus into minus is, it is a positive. So that we just got it as a negative side of the minus 1. The slope of the tangent is negative side of the minus 1. Suppose it is x is equal to minus 1. Negative side of the minus 1. The slope of the tangent is positive. One second. Original. The first thing is correct only. Negative side of the minus 1. The slope of the tangent is positive. Now check the right hand side of the minus 1. Right hand side of the minus 1 is nothing but 0 is there. At 0, what is the sign of f dash of x? 0 plus 1, 0 minus 1, 0 minus 1, or else 0 minus 1 minus 0 plus 1, 1, minus into plus, minus. This is a positive, negative. So here it is a negative. Now we can conclude that f dash of x changes the sign at left hand side of the minus 1 to the right hand side of the minus 1 as positive to negative. It changes the sign from positive to negative. Then by the first derivative test, what we can say that? By first derivative test, f dash of x is changes the sign from positive to negative. Therefore, we can say that f of x has the local maxima. F of x has the local maximum. Are you clear? It has a local maximum. It has a local maximum means f of minus 1 has the or is the local maximum. So therefore f of minus 1 at x is equal to minus 1, or else we can say that this is the point of local maximum. So at which point, or left hand side of the point and right hand side of the point, it changes the negative to positive means it is the point of local maximum. It is the point of that local maximum means f of that point is said to be a local maximum. So f of minus 1 is the required local maximum. What is the f of minus 1? F of minus 1. Wherever f of x is there, replace the x value is minus 1. Minus 1 cube. Minus 1. Minus 3 into minus 1. Plus 3. Plus 3. Plus 3. Plus 3 plus 3. Plus 6. 6 minus 1 is equal to 5. Therefore, this is the required local maximum. Local maximum value is 5. Suppose. Next, if it is a local maximum, then what about at x equal to 1? At x equal to 1. Already know that left hand side of the 1, the slope of the tangent is negative. Because 1 negative side, left hand side, 0 is taken, so it is a negative. It is sufficient to take the right hand side. If I take on 2, right hand side of the 1, 2. What is the sign of f dash of x? 2 plus 1, 2 minus 1, cos 2. It is a cos 2. So that f dash of x changes the sign on at x equal to 1, left hand side of the 1 to the right hand side of the 1 is negative to cos 2. It changes the sign from negative to cos 2. So by the first derivative test, at x is equal to 1 is the point of local minimum. It is the point of local minimum. So that local minimum value, that is the f of 1. F of 1 is 1 minus 3 plus 3. 1 minus 3 plus 3 plus 3 minus 3 will cancel is equal to 1. Therefore, this is the 1 is the local minimum value. 1 is the local minimum value. So this is how we have to solve we have to find the points of local maximum and the local minimum of the given function. For the given function, first find the derivative, then equate it to 0, find the critical points, left hand side of the critical point, right hand side of the critical point, how the f dash of x changes the sign, positive to negative, maximum, local maximum, negative to positive, local minimum. So it is, this type of problems is already solved in increasing decreasing. Little bit changes. Here, instead of writing the interval, we have to write the points of local maximum and the local minimum. And one more thing, remember that suppose particular node, if f of c is the local maximum value, f of c is the local maximum value, then c must be the point of local maximum. If f of c is the local minimum value, then c is the point of local minimum. Very important point. And vice versa. If c is the point of local minimum, then f of c is the point of local minimum value. This is how we have to solve the problems by using the first derivative test. So one more theorem is that is second derivative test. We just taken up first derivative test. One more test is the second derivative test. We will continue in the next video. What is the second derivative test and how to solve the problems on the second derivative test? We will see in the next video. Okay, thank you.